All right, good morning, good afternoon, good evening, everyone, depending where you are. Welcome to day 4 of the first ever virtual LabKey user conference. Hope you've been enjoying the last few days of content. And we got another good day full of fairly technical content today, although we're gonna try to keep it open and available to everyone who's here. So I'll just do a quick review of the agenda for today. I am actually I should introduce myself. I'm Adam Rauch, co-founder and vice president of product strategy here. You may have seen me on the first day where I presented an update on LabKey server. Today I will be presenting LabKey MyStudies, which is a LabKey based open source system for conducting IRB approved clinical trials, collecting patient-reported outcomes, and obtaining electronic consent for clinical trials and potentially clinical testing, all built on LabKey and available for your use. So I'll be doing an overview of that. Next up, we have Karl, who will be talking to you about automating your data import and data processing using file watchers. We will then move to Susan, who will be talking about the build system, in particular, how our external developers can leverage Artifactory and our Gradle build system to pull down pre-built artifacts to save you time, make you more efficient, and reduce the complexity of builds if you're building software on top of LabKey. Nick will be focusing on JavaScript development, in particular building modules, LabKey modules that leverage client-side development, leverage JavaScript. So if you're a client developer or a LabKey module developer, or you want to be a LabKey module developer or client developer, that'll be a great presentation to see how to integrate those technologies. Binal will be bringing your data together. Specifically looking at external schemas, external data sources, linked schemas, and how to leverage those existing features with ETLs to pull data from a variety of different sources, potentially on a one-time basis or on a recurring basis, depending what your requirements are. And then we're going to wrap it up with Isa and Stuart divulging everything they know about hosting LabKey, deploying LabKey in a cloud environment, and all of the complexities and best practices there that they have learned through the years. All right, so with that, I will jump into LabKey MyStudies. So this is a project we've been working on for about 4 years. I've been overseeing the design and the architecture and the development of this system, working with the FDA and some other partners. So as I kind of alluded to in my agenda, LabKey MyStudies is an open source system for conducting IRB approved clinical trials, collecting patient reported outcomes, and obtaining electronic informed consent using mobile devices. And importantly, using each patient's or participant's own mobile device. So it consists of a few different components. At the very high level, there's of course a mobile app. There are versions for iOS and for Android. There is a study designer web application that is used to design studies, surveys. All the content that goes into a study is designed using a web application. And there is a secure storage backend that then holds all of the responses for surveys, active tasks, all of the consent information, eligibility information, all goes to a secure backend where then research organizations on a secure basis can obtain that information and do downstream analysis. So I like to talk about some of the key characteristics. This is not the first system that has ever been used to, collect a survey using a mobile app. So what sets MyStudies apart from some of the other existing systems So first off, now, as I said, it's based on LabKey server, so these first three are probably not going to be too surprising to you, but they do kind of set MyStudies apart. First of all, it is very scalable. So it's designed to be multi-tenant, to be able to run many, many, many studies from multiple research organizations all at the same time in a single system. It is, well, based on LabKey, so it is secure. As usual, all data are partitioned into folders and projects, and our role-based security model is applied on top of those folders, and that allows us to, allows research organizations to conduct their research and know that all of their data is secure and, you know, partitioned from everyone else. It can be deployed in a compliant manner. So we deploy the backend, we host the backend for the FDA, and as you might imagine, they're fairly interested in HIPAA, FISMA, and Part 11 compliance. And so we have built these controls into the software, and we deploy the software with, you know, the appropriate compliance ceremonies and best practices and controls to ensure compliance with all of these regulations. The system is very configurable. First of all, the mobile app itself can be branded. So it's the same mobile app, it's the same software, but it can be deployed in a branded manner. So many of the studies that are currently run in the system have their own version of the mobile app in the app stores with their logos and their branding. But under the covers, it's really the same software, the same mobile app. It is also, importantly, as I mentioned, all of the studies, all of the content is configured via a web application. So there's no programming of the software, no programming of the mobile app or custom versions of the mobile app, just because you have a new study, new content, new survey, new question, active task. That is all configurable through the web application. It is in wide use right now. So there are currently 7 large-scale clinical trials using the MyStudies system, the system that we are hosting for the FDA. And there are more on the way, as you'll hear about shortly. The whole system was funded by the FDA. So they funded all of the initial development, all of the support, all of the hosting, and they continued to fund this system. So they're continuing to put a lot of funding into additional enhancements that we have built and our partners have built in order to support the requirements of the research organizations. They use the system, they give us feedback, we create new enhancements and new capabilities to keep that software continue to grow and improve. They're also paying for the hosting that LabKey is doing. They're also paying for support of third parties. So organizations like yours who are interested in evaluating MyStudies, they will fund our support of your evaluation. We're happy to answer questions. We're happy to, get you on board. There's a demo version of this whole system that you can use that is funded by the FDA. So this system is continuing to evolve and improve, and it's fully supported by the FDA and by LabKey. So fundamentally, the bottom line is this is a resource that's available to you. It's been built and funded by the FDA already, and it's something that you can use if it's of interest to you. So a quick timeline here. Started about 2015. Dr. David Martin, who was at the time Associate Director for Real-World Evidence at CDER, the Office of Medical Policy at the FDA. Just a little side note, fun fact, David retired from the FDA earlier in the summer and is now Vice President of Pharmacovigilance at Moderna. So we get to continue to work with him, and obviously he's very busy right now with the Moderna vaccine trial. Harvard Pilgrim, was selected in 2016 as effectively the systems integrator. That's probably, I put that in quotes because it's probably not exactly the right term, but you know, they oversaw all of the development of this system and helped with IRBs and helped with the, you know, the original clinical trials that went into this system. And then they issued an RFP, and LabKey and a company called Boston Technology Corporation, or BTC, were hired or selected as technology providers for the system. The next year, we developed that initial system, and we conducted a pilot study. This pilot study was of pregnant women and their drug use and potential adverse events. So it tracked these women over the course of a period of time, over the course of their pregnancy. It was, you know, primarily a test of the system to see, could we, you know, did it work? Did they use the system? Did they use the mobile app? Did they like the mobile app? Were we providing enough feedback to these participants that they were engaged? And at the end of the day, could we gather the data that they had provided and combine it with electronic medical records for those same participants who were patients at a particular hospital system? And that was successful, and there are papers out there that you can read about you know, what we learned from that process. Next year, we added more enhancements. We did a beta study through the FDA. And then the next year, we onboarded 2 large clinical trials from 2 different advocacy groups. Spark IBD is an IBD study. Limit JIA is a juvenile arthritis study. You can look those up. They're obviously they're public. We onboarded them, and they are conducting fairly large clinical trials through the system. And then this year, importantly, FDA announced COVID MyStudies, which is essentially, well, I'll talk about it in a little more detail, but it's a program of the FDA to, in the midst of this pandemic, to in particular focus on electronic consents and how do you collect informed consent from COVID-infected or potentially COVID-infected patients in a way that is safe for medical professionals and others. That they, you know, early in the pandemic, they identified that as a real problem. How do you conduct any clinical trial without, you know, using paper, essentially? And as it happened, the system that we had already built was really well tailored to that particular problem. So, COVID MyStudies. The FDA, this is a free program that the FDA has launched to basically, you know, help with informed consent when face-to-face contact is dangerous. So there's some requirements and some limitations of this program. Requires an investigational new drug number. So it's only for, you know, IND-based studies. And the focus, really the limit is on electronic consent. There are many more things that MyStudies does, but this particular program focuses just on the electronic consent aspect. Now, at the bottom line, this is the same MyStudies backend that we're using for those advocacy group trials that are going on. So we have now seven different clinical trials. Some of them are part of the COVID MyStudies program, and a couple of them are, you know, are sort of full-featured studies. But it's the exact same backend. It's, you know, effectively the same mobile app, although there is a COVID MyStudies branded mobile app in the App Store. And if you wanted to, you could download it right now. Just easiest thing to do is search for MyStudies in either the Apple or the Android App Store. You can download it. You can look at it. You won't be able to participate because you don't have an enrollment token, most likely. That is required in order to connect and enroll. So I should say you know, and you'll see if you download this app, you know, who's using it. It's, you know, it's all public information. Both the Moderna and the AstraZeneca COVID-19 vaccine trials are using the system for electronic consent. There is a remdesivir treatment trial also in the mobile app. And then there are a couple of other studies that are actually, they're not COVID studies themselves, but of course, any study, you know, at this time can have problems collecting informed consent from patients in general. So there are a couple of other, you know, non-COVID studies that are using the platform. And there are quite a few others in the pipeline right now and will be showing up in the app. So at the high level, the system, the whole system, it is a system, right? And it is comprised of really 4 different components. I've talked about the mobile application already. So obviously participants, patients, download that mobile app, the appropriate mobile app to their device. That single app can adapt to any different study that is sent its way. And as I mentioned, it can be branded. There's then a web-based configuration portal, or WCP. I sometimes call it the study designer, because that's what it is. So a study administrator uses that system to upload and update all of the content for a study. So the eligibility questionnaire, the consent information, resources that might be helpful to the participants, all of the surveys, whether it's initial, weekly, monthly surveys, all of the questions, all of the active tasks, what we call participant properties can be configured. And notifications and recurrence of all of these surveys, that can all be configured using a very easy to use web application. And then there are 2 more servers that collect information from the participants. There is a registration server. This holds the consent forms, signed consent forms that are sent to it once a participant consents. It holds participants' preferences information, login information. So just some of the kind of logistics type information needed for the study. And then there's the response server. This server does a lot of different tasks, but its fundamental role is to process and store all of the mobile app survey and active task responses, and then provides secure access to those data to data analysts. And that can be done on, you know, a continuous basis. It can be done on a, you know, at the end of the study, whatever the research organization desires. And then, as I alluded to before, the data analysts can pull all of those responses in, well, they can do analysis directly on LabKey server as usual, or they can pull that information into other analytic systems and join it with their electronic medical records or their registry as appropriate. So I'm going to quickly walk through the mobile application and what it looks like. I'm starting here. This is actually, you know, if you've downloaded that COVID MyStudies app, this is exactly what it looks like. This is a screenshot I took yesterday of COVID MyStudies. So there's obviously a welcome screen. And then in the case of COVID MyStudies, you'll see a list of studies. I've kind of captured the, you know, 4 of the 5 studies here. The 2 vaccine trials for COVID-19, Moderna and AstraZeneca, and, you know, a couple of others. Participants then choose the study, and they need to enter an enrollment code, an enrollment token. At that point, they enter the enrollment and consent workflow. This is the workflow that has been configured by the study administrator. So as you can see here, it might, you know, so there's eligibility information, consent information. It might include tests along the way to ensure that participants have understood what they're agreeing to. And then finally, they consent by signing either the patient themselves or their legally authorized representative. Those options are all exist in the system. And then we proceed with surveys and tasks. So surveys are scheduled, notifications appear on the mobile app. Obviously, it all depends on what kind of study, what kind of trial is happening, but demographics information might be collected, physical activities, surveys of various kinds. Those are all, sent to the participant at the appropriate time, and they respond. Now, importantly, we spent actually a lot of time and learned some things in the pilots and the beta studies around participant engagement and making sure that we provide feedback and mechanisms to keep patients engaged. And you can't just keep sending survey after survey after survey after survey without any feedback, or at least we believe we get better results if we provide dashboards and resources, as you see here. In the case of the pregnancy pilot, for instance, there was a kick counter included in one of the surveys, and then the dashboard would present that information. We basically graph that information over time. For this population, that was very interesting information. It gave them some incentive to answer the surveys and provide information. So at this point, I'm going to just pause and see if we have any questions that have come in. I have more information about the back end. I haven't really gone into a lot of detail on that, but I want to see if there are any general questions that folks have.
Yeah, thanks, Adam. I do see one question's come in. Is there a calendar view of the study activities as opposed to a listing of activities?
That's a good question. I'm not sure I know the answer to that. I haven't actually participated in any of these trials myself. Generally speaking, the main impetus for participants is going to be notifications that come in at the appropriate time. So they get notified. If they answer the survey at that time, the notification goes away. If they don't, they will get some reminders. So I don't know that we really provide a calendar per se. Now, certainly you could present that at eligibility and consent time. You saw, I went through quickly, but there was a screen about how is data collected, what do we do with this data, and in that process, you could certainly provide a kind of a calendar view of that information.
Thanks. That looks like that's it for questions for now, and we've got about 5 minutes left.
Okay. So I will probably spend most of that 5 minutes on this diagram because this really shows that entire back end, all of the components, and how the pieces fit together. So I think, let's see, I will get a pointer here. All right, everybody see that? So I'm just going to walk through the process, and in that process, I think I can kind of cover a lot of the the interactions here and the data flow. So basically, as I've talked about, a coordinating center or maybe the research organization itself. So it might be a coordinating center like Harvard Pilgrim or LabKey, or the research organization themselves design the study using the WCP. And then the research organization generates enrollment tokens from the response server. And what that basically means is, so these are enrollment tokens that uniquely identify each participant. As a research organization, you assign those to your, your prospects, your participants, and distribute those. And then those participants can, if they choose, they will download the mobile app, and they can then enroll using that token. So enrollment tokens go to mobile app users who download the app. If they consent, they're then enrolled. Their consent forms go to the registration server, and then they begin receiving study information. So the study metadata goes to the mobile app that customizes all the screens, all the surveys. Those responses go to the response server. And then at whatever point they want, the research organization on a continuous basis or periodically can pull down the consent forms, can pull down the responses from the response server. And if they choose, they can combine based on that enrollment token that they have saved away in their system, in their registry, EMR, what have you. They can join the data they have with the responses. And in that way, we have purposely kept the user registration server and the response server as separate servers. They're both based on LabKey server. There's no technical reason why they couldn't be the same server. But from a compliance standpoint, we've chosen to put protected health information or PII into the registration server. That allows the response server to be completely free of identifiers. So just a quick glimpse at the WCP or Study Designer. Again, as I've mentioned, web-based front end, very easy to use wizard type interface to configure studies. The registration server is an instance of LabKey server. So this UI might look familiar, but basically the consent forms are collected there and presented as PDFs in each secure folder associated with each study. Response server is used to generate those enrollment tokens. You can see in this case, I'm generating 1,000 enrollment tokens. I can then export those as Excel or export them as in a text format in the usual LabKey way. This should look very familiar to many of you. And then since it's LabKey server, all of those data analytics options, everything we've talked about for the last 4 days, as well as what some of our speakers today will be speaking about. Wide variety of options for analyzing the data directly within the response server or pulling that data into downstream systems.
Adam, could I break in? But there's another question from the audience that kind of is on that same topic. Is this IRB compliant at an academic institution?
Yes, it's designed to be IRB compliant. Obviously, it depends on your IRB. But all of the studies that I mentioned or that use MyStudies right now have been IRB approved. There are, as I mentioned on the previous slide or showed on the previous slide, support for a variety of different controls to protect PHI, et cetera. So in short, yes. Just to wrap up, you've got a number of deployment options. I talked about FDA COVID MyStudies and some of the good things and some of the limitations of that option. LabKey has its own deployment of MyStudies that is available to those. So this is a multi-tenant, full-featured version of MyStudies, surveys, compliance, and all those data analytic options are available. And that is supported by the LabKey services team that you know and love. You do have the option of deploying this software. It's all open source. You can deploy it in your own environment if you wish. And then, as I mentioned before, there is a demo environment that can be used for evaluation purposes. That's sort of, it's sort of, on the side of these other 3 options. That would not be used for an actual clinical trial or study. But that is an easy way to evaluate the software to see if it's appropriate to you. And then resource-wise, here are a couple of links that might be helpful. The announcement from the FDA about COVID MyStudies, a webinar that we presented. It's now almost 1.5 years ago, but it's all that data or all that material is fairly up to date. This was really a day-long webinar where we presented everything in detail about MyStudies. The FDA sponsored it, FDA presented, Harvard Pilgrim, PTC, and LabKey. And then I'll just say, send me an email if you're interested in hearing more. It's obviously just kind of scratch the surface, but be happy to answer questions or get you connected with the demo environment or the LabKey deployment. All right, so with that, next up we have Karl. He's going to tell you all about file watchers and how they can be used to automate your pipelines, your imports, and your processing.
Thank you, Adam. So like Adam said, I'm going to be talking about file watchers today. I'm going to try to give you, walk you through sort of an overview of what file watchers are, how to create them, how to configure them, some tips and tricks. And hopefully at the end of this talk, you will have enough information that you can take advantage of this tool to help you and your organization. So file watchers are part of the LabKey automation toolkit because, you know, why do something manually when you can automate it? We've had file watchers for several years now, and we've slowly added new features and functionality. At a high level, a file watcher is a process that watches a specific location on your file system, and it's looking for either the appearance or a change for a specific file pattern. Once it sees that, it sort of triggers an action, you know, a task which, you know, is a file watcher task or a file analysis task. It's important to note that the file analysis task is a pipeline action, it's a pipeline task. And so being so, the tasks run in the LabKey pipeline. And so one of the benefits of that is all the positive things about running in the pipeline are available, the background processing, the consolidated logging, notifications, etc. The other thing to note is that you can configure more than one file watcher for every folder and have them do, you know, different things, separate things, and looking for different types of files. And given that most of the time the file watcher is going to modify data on your server, you do need to be an administrator to either create, update, delete a file watcher. And then lastly, this is a premium feature. So any of our clients who have starter and above have access to this. So a couple examples of existing file watchers that we have in the system. You can load data into either, you know, lists or data sets. For data sets, it can be used to create a new data set or import into an existing data set. For lists, the list has to exist for you to load data into it. Additionally, we have file watchers to load, import data into using a study or a folder archive. And these are the folder archives. Those are the zip formats that are available for, you know, exporting either folders or studies. Additionally, you can load a folder of FCS files if you have the flow module, and import specimen data into a study specimen repository. And the specimen data that you can import could consist of an entire specimen archive, or it can be the individual pieces of a specimen archive, you know, the vial information, or any of the primary or additive or derivative types. You can also move files across the LabKey server file system. And this is pretty exciting. This is a recent feature addition, is we now allow you to expose custom script pipelines. And I'll talk more about this later in this talk. Okay, so how do we create file watchers? there's a couple of UI options available, either through the folder management import tab or from a study in the managed study page. There's File Watchers link. And from both of these, you'll see sort of the similar UI where it is a list of specific file watchers that you can create that are in scope for the particular folder that you're in, as well as there's a button at the bottom to manage existing file watcher triggers, which would include creating new file watcher triggers or deleting them or editing. Additionally, there's a general purpose UI available through the schema browser. If you if you look at the trigger configurations table in the pipeline schema, you'll see this grid view. And so it would show any of the existing file watchers that you have, as well as give you the opportunity to edit or delete them. And this is the, in the previous screen, the manage existing file watcher triggers. This is the view that it takes you to. Okay, so creating and configuring, once you're editing or you're creating a new file watcher, it'll drop you into our configuration wizard. And we built this a few years ago to be a general purpose editing tool. And while certainly there are some usability issues here that we'd like to address at some point, but it's certainly a large improvement from folks who have seen earlier versions of the file watcher editing the raw JSON. So in the first page of the configuration wizard, you have name, description, the pipeline task dropdown has a list of all the pipeline or the file watcher tasks that are in scope. And then the run as username, this is the account that the file watcher task will run under. And so it's important to note that you want to make sure that the user account that you associate with the file watcher has the appropriate permissions to do whatever actions need to take place. And so it's not necessarily the person who drops the file who is going to run in this context. It's going to be this username. And then there's the enable, disable checkbox as well. So the second page of the wizard, a little bit more interesting options here. You have the location. So this is where in the file system that we are looking for a particular file pattern. And this can be either an absolute or relative path. And if it's a relative path, it's relative to the current, the pipeline route of the folder that you're in. If it's an absolute path, you can go outside of the pipeline route. The include child folders option gives you the ability to search in subfolders of the location up to 3 subfolders for the file pattern. The file pattern, this is a regular expression that we'll talk about a little bit more because there's some complexity in here. This is basically the pattern of the file that you're searching for. Quiet period is the amount of time between once the file is triggered and the action takes place. So this can be useful if you have a configuration that is processing more than a single file, or you're on a network share and there's some latency, and so you want to wait for the transfer to finish. And then
Karl, I wonder if I could break in.
Configurations.
Oh, I'm sorry. Karl, could I break in with a question that's relevant to the previous slide? When you configure a file watcher, does the username also need to be an admin? No, it doesn't. It doesn't have to be. It could be a. So, like I said, it's
it can, as long as there are the appropriate permissions to accomplish the task. So many times you're writing data, so you probably want to be an editor, but no, they don't necessarily have to be an administrator. And so you probably want to configure it with the minimal amount of permissions needed to accomplish the job. If that makes sense.
Thanks.
Yep. Okay, so wrapping up the configuration, we have a couple move parameters here, and move options can be either relative to the current folder or absolute. And so the difference between move to container and move to subdirectory is move to container is container in the sense of a LabKey folder. So if you're navigating from one folder to another, the subdirectory refers to the virtual file system of the file root that you're in. And so some of you may have noticed that if you look at the files web part, you can create subfolders in there. So that's the virtual file system that I'm referring to here. Copy file to, this is again an absolute relative path to copy the triggered file to, and then this last piece, most people will probably not end up using the parameter function, but it's a programmatic way to modify some of the file watcher parameters before it's run. And so, one example of this is maybe you want to change the user that a file watcher is run on, depending on the incoming file. And so there's actually an example of this scenario on the LabKey documentation site. So it's basically a JavaScript function that is evaluated, and if it evaluates to a map of key value pairs, those are the parameter and the value you want to use that is substituted in. Okay, and so at the bottom here, I'll talk about this in the next slide, which is adding custom parameters. And so if you click on this link, it'll add sort of a name value combination that you can use for the particular configuration you're using. So custom parameters, some of the file watchers have custom behavior that can be controlled via the custom parameter. And so, for example, for lists and data sets, the default behavior is that when data is loaded or reloaded, we will completely replace all the data. So sometimes this is not desirable, and so you can control this via the merge data parameter or the default dot action. And so if we're updating, then it's only going to add new fields and update existing fields. Additionally, there's the allowed domain updates, which normally when we see new data, if there is a new field, we're going to add that field to the list or data set. And conversely, if we have existing columns, but that they don't appear in the incoming data, we'll drop those. And so, this may not be desirable either. And so you can control that with the allow domain updates flag. For steady reload, you can query validation as well as fail for undefined visits. And these are similar options that you see in the UI when you manually do a steady reload. So it just mimics those existing ones. And then for specimen reload, you have the option of merging or replace as well. Okay, so I'm going to move on to some more advanced configuration topics.
Before we do that, could we have one question? Could you address one question? So
Sure.
is there a way to define a custom field separator in the parameter function? Or maybe,
A custom field separator.
or maybe that's an advanced topic. Well, let's follow up. Let's follow up after. We can follow up after the presentation on that one to find out what's next.
Right. So yeah, I'll talk about substitution parameters as well as a concept called regular expression name capturing groups and how you can use them to take a little bit more advantage of file watcher configurations. But first I want to mention briefly about regular expression specificity. And so you can have your file watcher be essentially, a wildcard, basically say all files or all files of this extension. You're almost always better off being a little bit more specific and having a narrower regular expression to capture specific files. And part of the reason is if you start having multiple file watcher configurations for a folder, you do run the risk that more than one file watcher is going to operate on the same file watcher trigger. And most of the time, you don't want that to happen because it can induce side effects. So let's talk about substitution parameters first. These are a way to assemble file watcher configurations using substitution parameters. And substitution parameters are sort of a concept that we use over again in LabKey servers. So if you're familiar with URL formatting, you'll see sort of this similar syntax, the $ curly brace parameter. And so here's an example of a substitution parameter. Say you're making a copy of your file watcher, the trigger file, for auditing purposes, and you just have a copy, but you don't want to dump them into the same folder. Maybe you want to organize them from in a way that timestamps them. And so we have a built-in substitution called now:date, which accepts a format string. And so this particular this would resolve to this type of folder, so process 2020-10. And I'm going to switch gears and talk about name capturing groups, but I'll circle back to substitution parameters a little bit later. And so name capturing group is a feature in regular expressions that allows you to associate a name with a capture group. And so the syntax is sort of the capture group, the question mark name, where followed by the regular expression. And so as an example, look at this regular expression where we have the name capture group called name following the list underscore prefix and ending with the underscore trailing whatever text file. And so if we present this name, the capture group would be lab location and the capture name would be name. And so one way that you could use this is for lists and data sets. You can use these to associate with an existing list or data set. And the normal behavior, the way we match up what list or what data set to import is by the name of the trigger file. And this may not be convenient all the time. And so, it's nice to be able to specify the name or the list ID or data set ID that you want to bind to. And so here's a couple examples where we have the regular expression. So in this first one, for the list, we want to associate with a specific list ID. And so this file name would sort of extract that ID and bind it to, we would go and look for the list which had an ID of 345. And this next example is an example where we're going to bind the name for a data set import, and we're going to bind that to demographics. So given this file, we're going to associate that with an existing data set named demographics. And so kind of bring this around and looping back to substitution parameters, name capture groups are available as a substitution parameter. So it's a little bit abstract and hard to get your head around, but let me provide an example. Say you have several studies that you want to load data into, but you don't necessarily want to configure a file watcher configuration for each of them. One thing that you could do is you could specify the name of the study or the name of the folder that you're interested in as part of the file pattern in your file watcher trigger. And so if we look at this example, we have two name capture groups. One is this first part, and we're calling it study, and the second part is name, which, as we talked about in the previous slide, you can use to bind to either a list or a data set. And so then if you have this move to container configuration, it's using the name capture group study as part of the folder path. And so if we look at this file that we intake, it's going to grab that first part and it's going to move it to the folder studies/study-105 and import it into the demographics data set. And so a similar example is on our website and on the docs page as well. Okay, so custom script pipelines, mentioned this earlier. We've had script pipelines, module-based pipelines for a while here. In the 20.7 release, we allowed the ability to expose these as file watchers. And so if the module is enabled, you'll see your file watcher task appear in the dropdown. One of the cool things is that script pipelines, you can assemble them and they can contain a mixture of your custom actions that are, or tasks that are written in your scripting language like R or Python, but they can also invoke existing pipeline tasks like a list import or a data set import. Additionally, if you're writing in one of the, using one of the libraries that we have LabKey API support, you can invoke LabKey APIs using, such as select rows and the query APIs.
Hi, Karl. I
Okay,
wonder if I can
so,
jump in. Hi, Karl. I wonder if I can jump in with another question that came in as we're getting close to the closing. You mentioned when script pipelines were added, but what version when did file watchers become available? Was the question we got.
Oh, you're testing my memory.
I actually have the answer. I have the answer offhand if you need it.
Yeah, I thought it was in
2017. Yep.
Yeah, so a couple years ago, 3 years ago.
Thanks. And we're at about 3 or 4 minutes.
Okay, well, nearing the end. So I wanted to talk a little bit about troubleshooting because sometimes your file watchers don't work as expected. And so what do you do? So usually these fall into two categories. One is my file watcher configuration. It's not picking up the file, so nothing's happening. And so some obvious things to check. Do you have it enabled? Sometimes, so has the file previously been processed? So we do track when we take action on the file, we timestamp it just so that we don't process the same file across server restarts. And so unless the timestamp is newer than the last time we ran it, that file watcher will not be picked up. Additionally, some file watcher types are specific about the extensions that they will allow. And so here's a list of, for the list data set, specify an import of the allowable types. And then if your pipeline job does run, but something is, goes wrong with it, definitely look at the pipeline log for errors. Additionally, we write out log information in the file watchers. And so normally those would appear in the LabKey log. But one nice trick, especially when you're in the development phase of this and you're trying to troubleshoot, is you can, for people who are not familiar with this, you can temporarily override the configured log level. And so to do that, you go to the admin console loggers, and you can basically adjust for any of the loggers in the system. You can adjust them to debug, info, warn, error. And so the logger class that you wanted to use is the pipeline service class. And what I usually do is either have debugger info, lower it to that, and then you'll see more information spewed to your log file. And a couple resources. So here's links out to the FileWatcher docs, as well as some information on script pipelines and how to author them. And with that, I will take any questions if there are.
Yeah, thanks. We do have a couple of questions that have come in. One is, how does this work with cloud hosting? That is, can you watch files that are on a local, non-cloud file system? I think the question is, can I use this to watch files that are in S3 or on the cloud? And I believe the answer is no.
No, I think it has to be within the file system that LabKey has access to.
Great, thanks. And we're happy to follow up if there's more clarification, if I didn't quite get that question correct for that asker. And then another one, there was on the slide a couple back, there was a statement that a file type is not allowed for the file watcher. And does that mean the types that are allowed or not allowed below? And I'm not so clear what this question is asking, but I think going back to what would trigger file type not allowed? Yeah.
Yeah, so say if you wanted to do a list reload, and you configured your file watcher pattern, and maybe instead of .tsv, or maybe it's it's every file, but you dropped in a CSV file, and so it's, even though the file watcher pattern may match up, the particular file watcher task does not allow this particular file extension. And mostly it's because for the import of things like lists or data sets, we can import certain file types. Actually CSV should be allowed, but I think when we built the list and data set, these were sort of the obvious types that should be respected.
Yeah, and yes, and we just got a clarification of that question. That was the question: is TSV, XLSX, XLS the types that are allowed for lists? Yes.
Yeah. So this list is what is allowed.
Great, thank you. And it looks like that's all the questions that we have for now, and everyone's free to ask questions later, and we can follow up later. Thanks.
Okay. With that, I will introduce the next speaker. Susan Hert is a software architect, and she's going to talk about how to take advantage of Artifactory in your LabKey builds. You're still muted, Susan.
There we go. So today I'm going to talk to you about building less with more, by which I mean how you or some friendly developer that you may know can spend less time building the LabKey code by using more of the artifacts that we are building all the time and that you have access to. So, picture on the left is a depiction of sort of the traditional process that you are probably using now. That is, you take delivery of all of the various parts of your system, and then you or maybe your computer does a lot of work in putting them together, hammering all the nails, taping all the seams, putting up all the shingles. All of that work is done while you wait. And the process that I'm going to try to encourage you to move towards is depicted on the right, where you're still taking delivery of artifacts, but they're bigger. And so you don't have to spend as much time on hammering all the nails. Either process, of course, is going to end up with a beautiful structure that's going to be very solid and you can use it, but all other things being equal, the process on the left will take more time than the process on the right. And we are spending a lot of time already in building these larger artifacts and constructing these beautiful dormers. So we do that all the time, and you don't have to spend the time doing that. This is the example that I'm going to use throughout the presentation. And I should say, as with previous presentations, feel free to ask questions in the Q&A panel as I go, and we can try to address those at the end. So here's my example. It's just a simple LabKey deployment that requires, first of all, the base LabKey modules, the things that any LabKey server deployment needs in order for it to function, API core, internal query, things that you're very familiar with. In my instance, I also am going to require the NAB module. I'm doing some kind of assays, neutralizing antibodies. And I also want to use the assay modules API. And then I'm writing my own module. And just to ground it more specifically, this is going to be based on, I'm developing this on 20.9.0 release of LabKey. So the picture on the left that I showed you was what I'm calling the build all approach. And this is the one that you are probably very familiar with. It starts out with, you just enlist in the root repository, which I'll call LabKey root throughout this presentation. And then enlist in the platform repository, because that's where you get those base modules. And because I want the NAB module as well, I'm going to enlist in the common assays repository. And I'm also going to adjust my settings.gradle. This is not something that's actually necessary, but because both platform and common assays come with more modules than I need, this is my one nod towards, I don't want to build all these things that I don't need, so I'll adjust the projects that Gradle knows about by editing that settings.gradle file. Then, of course, I write my own module. I put that in the server modules directory, and then I do the deploy app. So as I said, this is probably the process that you're very familiar with. And we're going to compare that to what I'm calling a build own approach, where the first step is, of course, necessary because we need, the root of the repository gives us the build infrastructure, if nothing else. But in the very minimal case, I don't need to enlist in the platform. I don't need to enlist in common assays. And I also don't need to adjust the settings.gradles file because its default will do what I want to when I don't have these other enlistments. Of course, I have to write my own module in server modules, and then I do the Gradle deploy app. Now, just to give you a sense of the time difference, this is not scientific data that we're going to publish any papers about, but it is based off of numbers that I gathered from this machine. And so you can just see the significant difference in time. Of course, in all cases, we have to have the base enlistment. If you're not building with the artifacts, then you get the platform enlistment and the common assays enlistment. And then, of course, the biggest difference is when you do the deploy app, like how much time do you spend actually building? Now, of course, enlistment time is not something that you do all the time. It's usually a one-time thing, but there is more chance for error there because you might get the wrong branch, which happens more often than you might think, or you just need to update that enlistment as new code comes in. And of course, those who are familiar with Gradle know that it's pretty good about knowing when things haven't changed, and so it doesn't need to do a lot of building. But when you have the source code there are different reasons why it could trigger, oh, I need to go build all these things again. So there's just more of a possibility to spend all that time that you don't need to. So I'm going to start out, there are different ways that you can build own. And I'll give a few examples of these different ways and hopefully encourage you to try one of them. So the minimal enlistment is the example that I showed you first. So I'll start out there. And then there's the larger enlistment, which is probably closer to where you are right now, and probably what I would suggest that you try if you're in the build all mode and you want to try building less. And then there's building outside of a LabKey enlistment altogether, which is not for everyone, but if you're set up to do that, it's certainly a nice way to build only what you need. So I'll start out with the minimal enlistment example. So this is going to give you the largest artifacts, and you get to not see as much of what's going on, but you still get the artifacts that you need. So this process looks a little different. You only enlist in your LabKey root. You write your own module, obviously, in server modules. And then the key part here is that you adjust the dependencies for own modules so that you tell it, I need these other modules that my module depends on. And otherwise, it'll only deploy your own module. And then you won't have a running LabKey server, you'll just have your own module. Now, I will say that this is kind of bleeding edge. It requires the Gradle plugins version 1.18.0 or greater, and therefore LabKey 20.9.0 or greater, just because the plugins were originally developed with some assumptions about, well, you're going to be deploying a LabKey server, and so it assumes you've got some modules that you don't actually have to have, or you've got projects that you don't need to have. So in this scenario, this is what my file system kind of looks like. I've got obviously the LabKey root, which just has standard things. And then in my server modules directory, I have my own module directory, and then of course the build.gradle file that just comes from the root enlistment. And with that setup, I haven't changed the settings file at all. if I run the projects task, you can see that there's only one project. Well, there are technically three, but there's only one module that Gradle knows about. And so that's a good clue to you that it's the only thing that's going to be built because it just doesn't know anything about anything else. So here's the key part to making this work is you have to set up the dependencies so that when you do the deploy app, it knows which modules should be included in that deployment. Now, here I said my example is going to use the API assay, and so I declare a dependency. You know, my code, my implementation depends on something from API assay, and this is using standard Gradle syntax for declaring that dependency. Then I also said I need the nab module, and so that the second line in the dependencies block is saying for the modules configuration, which is the thing that our Gradle plugins use to determine which files, which module files should I copy into the build directory, I'm going to declare this dependency on one of these artifacts that that we're producing, which is a module artifact for the nab module. And because it is a file that has a sort of non-standard extension on it, namely the .module, I need to specify that I want this to be transitive. So when we publish our modules to our Artifactory instance, we try to publish the dependencies that any module has, and we want to pick those up. And you'll see what I mean when I get to the next slide. But another key part of this is that I need to tell it, I need all these base modules. I need the query and the API and the internal modules as well. And so this nice utility method from our Gradle plugins will do that for you. You can do that just in the same way we did for the nab module by spelling them out individually, but that's essentially what that add base module dependencies does for you. So having done that, if I now run the dependencies task for my module and look specifically at the module's configuration, you can see that it brings in the nab module that I specified, which has a dependency on assay, which has a dependency on experiment and pipeline and query. So I don't need to declare those in my set at all. And then it brings in, because I had the base dependencies, API, internal, audit, all of those things. And so this is the set of modules when I do a deploy app that will get picked up and put in my deploy directory. And then you are spending time only on building your own module, and you also download these artifacts, these .module files from Artifactory only once. And even if you do a clean build and build again, they're still in the cache in your local directory, so you don't need to build them again or pull them down. So that is the minimal enlistment example. And this is, I would recommend this for few circumstances. So one thing that might indicate this is right for you is that you don't have any need for looking at LabKey source code as a reference. You know your way around the code and you know what you want to do with your module. So you don't need that at all. Or as I said, you want to build as little as possible. And you're not interested in trying to write your own build tasks. So you want to use the Gradle plugins that we have to best advantage. And so you can do that by putting your module inside the server modules directory and just taking advantage of that. Or you also want to use the LabKey Selenium test infrastructure. And that really requires that you're inside the server enlistment for LabKey. And of course, you'd have to enlist in the test automation repository as well. But as I said, this does require a later version of LabKey and the Gradle plugins. So if you're not there yet, then this is probably not yet for you, but you might have your sights on this at a later date. What does it look like with a slightly larger LabKey enlistment? So in this case, you're still getting the large artifacts delivered to you, but you can kind of see inside a little more. And this process looks a lot like the build all process that I started with, but the key difference here is the introduction of this build from source property, which is a custom property that we have in our Gradle plugins that allows you to say which ones do you want to build and which ones do you not. So again, since you've enlisted in LabKey root and you've enlisted in common assays and platform, this is what your enlistment looks like, including your own module. And now if I run the Gradle projects task, you'll see that it knows about a lot more. So it knows about common assays and NAB and API and audit and all of that. So this might seem like, oh, well, it's going to spend time building all of those as well. But this is where the build from source property comes in. So our plugins, and in particular, the utility method that I'll show you in a little bit, called add LabKey dependency, will look for this particular property and obey its setting for your Gradle project. So in order to get it so that it builds only your module and not any of the other things that you have an enlistment in, you can set build from source to false at the root of your enlistment. And if you made no other changes, that would say, I don't want to build anything from source. And then it will fail because we don't have an artifact for your own module. But you can override that by, in your own module, you create a Gradle.properties file that has build from source set to true. And then it has this similar effect, not exactly the same, but a similar effect to the minimal example, where I'm building only my module, I'm not building anything else. And one difference here between the minimal enlistment and the I'm using build from source is the use of this utility method that I talked about. So the effect of this add LabKey dependency utility is to declare a dependency for a configuration to a particular project or artifact. But it has a lot of magic inside it that will check, do you have this build from source property set to true or false, for example, or do I not have that project in my my settings file, or do I not have an enlistment in that project? All of those things will help it determine whether it's going to build or it's going to try to find it in Artifactory. So this is what the build.gradle file looks like if you're using this larger LabKey enlistment and want to use that build from source property. So when would you use this kind of enlistment? And as I said at the beginning, I think this is where I would encourage you to start if you're doing the build all approach now, because this will be closest to where you are. But other indications are maybe sometimes you want to build from source for whatever reason. Maybe it's because you want to use the latest source. So you're keeping time with all the changes that we are making, and you really want to use that latest feature that we're developing. Or you want to have the enlistment so you can use the LabKey source code as a reference, but you don't really need to build it all the time. Or of course, if you're using a LabKey version before 20.9, then the first option isn't available to you. So I'll briefly talk about this other case, which is probably not going to be applicable to most people, but it is certainly viable. And that is you're building completely outside of a LabKey enlistment. So you're writing your own module, but you don't need this LabKey source code at all. And this process looks very different. You're writing your own module in some directory. You define the tasks in own modules build.gradle file to create a .module file, or you define the task in your build tool of choice to create a .module file. You run the build, and then somehow you get that .module file into the LabKey server deployment. This one is very flexible, and so I'm not going to show you an example of that because it will look very different on everyone's system. And where you might use this is if you already have your own build and test process infrastructure, and you don't like Gradle, you want to use Maven, you want to use Ant, or whatever, then this would be a path for you to follow. We do have an example of trying to, a module that is a standalone module that has its own build.gradle file. We have an example that uses both with and without the Gradle plugins from LabKey, and you can check that out on the documentation. Just some particulars on the artifacts that we are publishing. So starting with release 19.3, we have been publishing artifacts to our Artifactory instance. And there are two different kinds. As you saw in the example, we have the API jar files under the group org.labkey.api, and then we have the module files, the larger ones, under org.labkey.module. And for development and trunk, we publish roughly nightly, but for the release versions, we publish them when we make releases. And all of these are available. The community editions are available for download for anonymous users, but if you need access to one of our premium modules, then we need to set up an Artifactory account, and you can talk to your account manager and we can get that set up for you. So my recommendations for you are to try to build as little as possible. You are building all the time, and so making that as quick as possible will just make you more efficient. And I would also recommend that you try to use stable release version artifacts if possible. Building off of the nightly snapshots that we produce can sometimes produce a little instability in your world. We don't try to publish things that look like this, but it can happen. And so only if you really need to be on the cutting edge would you want to do that. And with that, I'm happy to take any questions that folks might have.
Thanks, Susan. Yeah, we did have a couple of questions come in. One from earlier in the talk: are module transitive dependencies false by default?
So because of I think this is why, I don't actually know, but Gradle does not, the answer is briefly yes, but I don't know why. So you have to declare that because the extension is not .jar, I think, and it's .module, then it does not set it to true. I'm not sure why.
Thanks. And the second question, why is Selenium, I'm not sure if this is the case, but why is Selenium available only with the minimal enlistment?
Yeah, so that's, sorry, that was not clarified. So what I was trying to get at there is that, in our build, our processes, we use Selenium to run a lot of tests. And we have the test automation module that you can enlist in and also use for building Selenium tests for your module. But currently, to use the test runner that we have, you really need to be inside a LabKey enlistment. So using that outside of LabKey is, you'll have to do a little of your own construction to make that work. I don't even know what would be required there. And so my only point was, if you want to write your own Selenium tests that use some of our Selenium classes, you really want to do that inside of a LabKey enlistment.
Thanks. One more. So what do I need to do to get access to Artifactory? Do I need to configure anything?
You do not. And unbeknownst to you, perhaps you're already using Artifactory because that's where we get the third-party jars that we are using. So for any of the community editions, these artifacts are available to you and you don't need to do anything. The only time you would need to configure something is if you need a premium module, then we'd have to get you set up with an account and you'd get a username and an API key and you'd put that in your configuration.
Great, thanks. And one more, is there a tutorial or documentation for Selenium, for using Selenium tests?
Molly, you're going to be...
I can kind of answer that. Yes, if you search in the documentation, we have some tools for getting started using Selenium to test your code. So it looks like, let's see. Oh, here's another question. Can I do any of this with an older version of LabKey?
Yes. So the built from source property has been around for a very long time. And so that is available for your use. I don't know what version that was in. So that's where I would recommend that you start. But the really minimal enlistment part is very bleeding edge. So.
Great, thanks. And one more. So what's the future of Subversion at LabKey? How much longer will we have a mixture of Subversion and GitHub?
A very timely question. It is going to be transitioned sort of immediately after this week. Sometime next week, probably, we will start the final move of the root enlistment to Git. So 20.11 at the latest, everything will be in Git.
Great, thank you. Very up to the minute technical presentations here. So I think that's our time.
Okay. And with that, I will hand it over to Nick, who is going to talk to you about JavaScript development with LabKey Server.
Sorry about that. Hi, my name is Nick Kerr, and I'm a senior engineer here at LabKey, and I'm going to talk about JavaScript development in LabKey Server. So let me get this presentation started here. All right. So the topics I'm going to cover today are the LabKey API package that we released earlier this year, and then talk about building client-side apps in LabKey. That's kind of going to be the main part of the talk. But let's dive into the API first. LabKey API package is a collection of endpoint wrappers and utilities that you guys might be familiar with. This is things like query select rows, security, create container, a lot of the APIs you use kind of on our LabKey pages per se. This has been rolled into a separate package in API, and we've been developing it for several years now, and we want to use it in our apps, and that's kind of why we started building it. But it is fully written in TypeScript. We export those interface definitions, so if you use TypeScript, you can leverage all the typings that we add there. We bundle it as a universal module definition distribution, so it should be able to run in your CommonJS or your UMD or ES6, however you are building your apps. You can use these tools there when you're on a LabKey page. And it is served under the LabKey namespace in LabKey server. So what this means is that when you pull up the page and you type all caps LabKey like I have there, we will serve up this package as the implementation for those. So you're using the same code whether you're on the page or when you pull the module down locally. This is just a brief example of what this looks like. So here I'm using LabKey API to call select rows. I'm going to fetch some user reports, for instance. This is wrapping it in a promise. I'm able to get the server context. This gives me access to things like the user information, the container. These are kind of like global constants that you would normally access in the page. And then I'm calling select rows, creating some filters for that, and then finally resolving my promise based on that. So it just shows kind of a more modern approach to how we're hooking up our endpoints to allow them to be accessed via JavaScript. Like I said, this is something we've been using for a few years, so it's pretty well tested, and that's why we felt comfortable releasing 1.0 and actually making it the underlying implementation for our client side. Let me see if there's any questions about that real quick. Okay. So now I'm going to move on to building applications. So this kind of builds on top exactly of what Susan was just talking about. But one thing is we do a lot of work in the client side, and so we wanted our build system to be able to support what we needed to have happen in our modules. The client side is kind of constantly evolving ecosystem of packages that are updating daily. There's lots of different frameworks and tools to choose from. We do a lot of React development ourselves, but there's people using Vue. You can incorporate Sass. You can use Webpack, React, Create, stuff like that. So the tenets are that LabKey modules are and kind of always have been full stack, meaning that you can go all the way from the database and writing SQL scripts all the way up to the client side and building really modern JavaScript apps on top of your modules. So this has brought about kind of professional grade client side support for these building of apps in our Gradle build. The main thing that we depend on is the fact that Node or NPM is used by our build system to kind of incorporate these things. I'll talk about that more in a second. But otherwise, you're free to use whatever client-side tools that you're comfortable with or your team uses. Like I said, we use JavaScript, and I'll be kind of giving an example of that later. We use React, but we'll give an example of that later. So the Gradle build integrations, the way we do it is when you're developing kind of modern JavaScript, a common thing is to have a package JSON file. This is normally declared as a NPM package's way of defining its metadata. This is where you can set up dependencies that you have on other packages. It's where you can define script hooks that you want to leverage that you run on the command line. Like you might run something like npm run build or npm test, for example. What we did is we leveraged that in our Gradle build and said, hey, we're going to expect a couple script endpoints to be there if you have a package JSON available at the root of your module. So if you define a LabKey module and you place a package JSON there, you can create a scripts tag and you can add a setup, a build, and a clean targets, and those will automatically get hooked and then run whatever command you want at that time. So setup is actually run, when it's deploying all the modules and trying to figure out what resources are needed for those. Build will actually build the app. So this can be the same command that you would run to run npm run build. This is after all of your node artifacts are already pulled down. And then you can see here we have a couple other ones that are more specific, and I can talk about those, but they are not a part of the build system. So as an example here of depending on LabKey API, you can see here that on the left side I've declared a dependency on that package, and this is how we incorporate it with our own modules. All right, so the next thing is modules have always been able to support file-based views and views served from Java. But we also wanted to be able to build apps and build multiple apps per se that within a given module. So we declared a pattern that allows you to define an entry points.js file. This entry point file sits in your module, and it declares some metadata about the apps that you have defined in this module. These apps, this app metadata, gives us the name, the title. You can incorporate what permissions you have, excuse me, for the app. This is a little bit like a Vue XML file, but it's defining like what we're going to end up placing in the Vue XML file. And then lastly is the path that you have to that resource in your module. If you define these, the module then, the build then knows, hey, I'm going to build all of these different endpoints, or excuse me, all these different apps and bundle them and produce their resources to be made available for the client side when you want to distribute it. So I'm going to dive into a example here. We're going to do some live coding. So the first thing I want to show is the tutorial demo. We have a demo module up on tutorial modules, which is available to the public. You can pull this down and use this as a reference guide for how we do things. We maintain this to kind of give our latest patterns for how we are building modules and provide this kind of resource for folks. So what you'll see here is the package JSON file. And then if you go into the source and the client, here's the apps that I actually have built out. And so I'm going to go over here to IntelliJ real quick, and you can see here that in my demo module here, I have it. And here's the package JSON I was talking about. Here's those setup scripts that we're able to run and hook. And then here's all the dependencies that this module requires. So I have a few apps defined here, and I've actually already loaded these up to run here. Let me log back in. And so this is an example of a simple React app that I have running in LabKey server. And so, I can say, make a shopping cart list, and I'm able to just interact with this app, and it runs in React in the page. So let's say that I wanted to make a couple changes to it. Let's say that I wanted to actually get rid of this aspect here, that just shorten up the title of this completed, just basically make a change. All I have to do is, now that I have the build system here, I'm just sitting at the root deployment, and I can just say, hey, Gradle, please redeploy my module. So I'm actually going to run that. And what you'll see here is it's going to hook the script hooks that I was just talking about. So it ran npm run build prod, and then it was able to run the command I actually asked it to run, which is to build my application. This is it displaying the artifacts. This would be custom to whatever your actual build does. Like, for instance, we use Webpack here, so it outputs what was emitted here. And then we copy it into the web resources directory of our module. So if I go into the resources, the web directory here, you can see all these assets that were created. IntelliJ recognizes them as not part of the project. But this is how we actually get the assets produced and pushed into our module. So this is kind of like the public directory. And then if I go back to here and I just refresh this page, you can see here that if I do this again, it's just going to say completed. It no longer has that additional title and text, stuff like that. So this is kind of the full cycle of development using Gradle to build the apps. I do want to actually show as well in here that we are using at LabKey API in here as well. So this is calling get server context, and this is actually going to access the user to get their display name here. So this is when it can say, to do items for Nick Kerr. So just as an example of kind of bringing it full circle and incorporating everything. Something else I wanted to briefly show was that for some folks, this demo has a reference of it, but I just want to show it real quick. We are able to do dynamic hot loading of components. So this is a React-specific feature. I haven't used Vue.js, so I'm not sure. It probably has something like this as well, I'm assuming. But now if I make these changes, I actually have a different endpoint I can go to. Go to to-do list dev here, and then this will actually be a live application that will reload as I make changes. So let's go ahead and add back some of that. Oops. Let's go ahead and add back those changes I was talking about, and I'll hit save here. And as soon as I hit save, you'll see that it actually recompiled the application as soon as I hit save. And if I go back over to here, I can still run the app, and I'm able to see the changes coming here. And so if I go ahead and undo those, just to show it in reverse, it actually already disappeared. So this was actually reloading on the page without the page reloading. So I'm kind of getting fully dynamic development, and it makes for really rapid development of our client-side tools. So this is what we're building. This is pretty much the workflow we build all of our apps in. So this is what was demoed yesterday for our electronic notebook, the sample manager that was demoed yesterday as well. These all use these tools. So that is all I have for that. Is there any questions?
We don't have any questions at the moment.
I think does
I
the
think
server
one
need to
did.
be in dev mode for the auto build feature to
yeah.
work? For the auto build feature to work.
For hot reload.
Oh, yeah, good question, Anthony. It does not need to be in for hot reload. You can just, since I'm running it as a separate process, I can just do that, and I serve it up as a different view actually. So it would work in production mode if you were running your local server action. It's because you are hitting that separate action. So. There is one other aspect I wanted to talk about. We are going to be releasing soon LabKey components, which is a set of components that we use. This is the stuff that we've been developing over the last several years that we've really battle tested and worked with. And this is stuff we want to release so that the community can leverage this against LabKey to help display data in a more efficient way, or in a way that looks similar to how we display data in our applications. So this is a package of LabKey classes and React components that are published by us. There's things there, like I said, for query modeling, for a grid. It's not as fully featured as the data region that we have, but it is the grid that we use in our apps that has a different set of features. And when I say details, I'm talking about being able to look at kind of at an individual row and have different rendering about the data in that row. Just like LabKey API, this is going to be published using UMD with TypeScript fully prepared. And so you guys can expect that 1.0 release soon.
So we have had a couple more questions come in. So, the first question is, can you kind of touch on the difference between the live refresh or the hot reload again versus the static mode again? Kind of just give a...
Yeah. So the difference is that when I'm running in the static mode, as you call it, just like kind of the normal deployment, it's going to actually be copying those resources and putting them in that directory, and then the server is going to be serving it up from there. What we do for our hot reload, like I said, it's kind of a reference example that's not built into Gradle itself. It's just a reference example that we have in the apps in the demo module. But what we do is we use a thing called Webpack Dev Server, and Webpack Dev Server is actually able to serve assets from a different server on the local instance. So for instance, my LabKey server is running on port 8080, and then it'll actually spin up a server on port 3000 or 3010 or whatever port we ask it to. And we'll actually serve assets from it, and it won't actually produce any files on the file system, but it will virtually serve those assets as they dynamically get loaded. On the browser side of things, when you, let me go back to here. It's actually probably easiest if I show it in here. So you can see here on the right side, there's a set of updates. So I'm going to go back to the app here, and I will change this to be completed. And you can see here that it actually brought those in immediately. And what happened here is you can see the app said, hey, I got notified that it's recompiling. It told me what modules, it refers to JavaScript files as modules. And so when it figures out what modules actually got changed, it says, hey, I need to reload these into the page. And then it dynamically loads those assets into the page served from that Webpack dev server, if that makes sense. So I'm kind of serving assets from a different server locally than my LabKey one. Hope that answers the question.
Another question we have is that what version of LabKey can folks start using these APIs? Specifically, they asked for the React API, but I think the question's really for.
Yeah, good question.
Yeah.
So we released 1.0 kind of officially with 20.7. So that was our most recent, full release. I think it was incorporated in 20.5, but you can use these APIs against even older versions because we try to keep the API endpoints themselves backwards compatible as much as possible. But we will be calling out if there's any versions that we don't support in the future. Like for instance, when we move to version 2.0 or version 1.5, if we say, hey, this only supports above a given version of LabKey for maybe a specific API, we'll say that. As for the LabKey component side, these haven't been released yet, but they're also somewhat LabKey version independent. They do tie into those APIs because at LabKey components depends on the API package to do some of its work, but you should be able to start using it. I would say with 20.7, 20.9, and certainly 20.11.
And so another question is, what's the difference between 1.0 and the React demo that's been available for the past couple months?
Sorry, do you mean 1.0 of the LabKey API or of the components one?
I believe 1.0 of the API.
Oh, so there's not much difference. We really tried to, the main difference is we actually served it on the LabKey pages to make it so that it was our backing instance or backing implementation, for the pages themselves. Otherwise, if you are already using this package, you probably won't experience much difference if you were using it kind of in our alpha phase. But yeah, our plan is to be able to now use this as a version controlled interface so that we can, move forward and, introduce things like promises, introduce different ways of accessing the data, deprecate some of our older APIs as we move forward. So not much different from the pre-alpha or the alpha versions, but yeah.
So another question, I think you'll really like this one. Will the components library replace the current web parts functionality and removing XJS?
That is certainly a hope of ours. We are ourselves moving towards that. We have, if people aren't familiar with XJS, XJS was a platform that we used in a previous time that we still use in a lot of our views. We use XJS 3 and XJS version 4. These have since been essentially deprecated. They're not really well maintained anymore. We maintain our own instances in LabKey itself. But our hope is to be able to leverage these components that are versioned and that you're able to easily pull into your modules with things like this build, that we can have people moving forward and off of XJS. Ourselves, we've been working over time to remove some of our dependencies on XJS, but it's kind of on an as-is needed basis. So we'll still have XJS in the product or in the server for a foreseeable future, but our app development definitely doesn't further any XJS development.
Nick, this is Josh. Since we've got a couple minutes
Yeah.
available in the time slot, it might be nice to show people some of the advantages you get out of using the TypeScript version of the API here in terms of editor assistance and things like that. kind of an incentive to use the newer style, even though we're backwards compatible with the old.
Sure, yeah, that's a great point. So if folks aren't familiar with TypeScript, TypeScript is a thing developed by Microsoft, probably started 6-7 years ago, something like that. And it allows you to have better typings around JavaScript. As you might know, JavaScript is an untyped interpreted language. So TypeScript wanted to allow people to say, hey, I actually know what the structure should look like, and I want to add interfaces and kind of have some more first-class coding paradigms wrapped into their code. So what you can do in TypeScript is define things, like I said, like interfaces and types. And these, when you do something like this, it's written directly into the file. As you can see here, there's an extension .tsx here. If you're using JavaScript, you might be familiar with JSX. So this is essentially saying, hey, this is a JSX file, but written in TypeScript, so it's called TSX. But when you compile this to JavaScript, all the TypeScript is actually taken out. It's by the TypeScript compiler because it's not valid JavaScript necessarily. And so, but when it is compiled through the compiler, it's actually going to enforce whatever interfaces and types that you have are made sure to be respected by your code. So as an example, I have this Git server context I was referring to. If I click through to this, I can see here that this actually has a type of LabKey, and LabKey is declared here in this constants.d.ts. A dts.ts is a definition file. It's basically saying, hey, here's the type definitions that are defined for a given module. So if I had a module called constants.ts, this would be the definition file for that same module. And this type here actually is fully declared by us to say what these types should be. And so these can be deeply nested types. You can have structures that are kind of fully defined. So when I do something like get server context, I can then do a dot here annotation in IntelliJ, and it fully understands TypeScript as well. And so it's able to see through these interfaces what should actually be provided and what the type of that thing being provided is. So if I wanted to see a user, then I can then look at the user and say, oh, look, there's information about whether the user's user ID, what their display name is, their email, some other properties of what we ship down to the client. So this makes it a little bit more explorable, but it also makes it so that your code is safer and more well typed. The double-edged sword of adding typings is that they're kind of as good as you want them to be, because you can kind of opt out if you did something like, oops, excuse me. You can opt out by doing something like any. So I can just say, hey, I don't have a type for this, just let it be anything. But it is as helpful as you want it to be if you make your types strict. So by us offering these types, it should help you write complete code, and also find out, if we update something or you want to move to a more recent version of our package, you'll be able to easily see those changes, because your TypeScript compiler will fail and say, hey, you're failing here. And as soon as you have a compiling build, you're really close to being probably good to go.
And kind of to just add on to what Nick was saying a little bit here, Nick and I have been using TypeScript extensively in the new ELN product that Bernie demoed yesterday. And we have really gone to town and made sure to have types for just about everything. We're very strict, and we essentially don't allow the any type at all. And as a result, it has allowed us to catch many different bugs in the code before we even commit the code or ship it. Or if the API changes, it allows us to make a change to our type definition that, because we added a new attribute or we removed an attribute or renamed it. And then as a result, you get a compiler error, which can be frustrating in some sense, but also it gives you the exact location of all the different places where your code is no longer valid. And this prevents you from ever even shipping bad code, which is just really great. If you've ever written JavaScript, you've probably had to deal with, cannot access, blank of undefined or what have you. And you will have a lot harder time introducing those types of errors if you are really strict on your typing. So I would highly recommend people take some time to look at TypeScript and consider using it, I think it's been a net benefit. It can seem like a lot to take on, but the nice thing about TypeScript is you can start small. All JavaScript is valid TypeScript. So as long as you know JavaScript, you can say that you know TypeScript, and then you can kind of just start small. And as you get more comfortable with the type system and how it works, you can really just start adding more and more types to your projects. And as a result, I think you'll end up having higher quality code with less bugs. And if you're looking for a good resource to get started, there's a really great book, not written officially by the TypeScript team, but it's called TypeScript Deep Dive. So if you do a Google search for TypeScript Deep Dive, you'll find a great book. It's really extensive. And it's I think is a really great introduction. It even has a little transition set of chapters that talk about JavaScript, modern JavaScript, and then how to transition from that to TypeScript. And I found that to be just a really invaluable resource when learning TypeScript. So I'd highly recommend taking a look at TypeScript Deep Dive and consider using TypeScript in your projects.
Great. I did want to show one other advantage we get out of TypeScript is that when we use it, we are able to leverage something called TypeDoc, which takes all those typings and produces a document for us, so that we're actually able to produce from code generated documentation. So what this gives us is that when you go look at select rows now, for instance, if you used it before, you might remember that you always had to go open the browser page to find out what was there. Now, using what I just showed in IntelliJ, you can find out what's needed due to the types that we declare. So it would say, hey, you need a schema name, requires a query name, that kind of thing. But additionally, I can actually go to the definition of these things in the source code, and you can actually see this whole interface here because this links through to our exposed interfaces in GitHub. So this will give kind of direct access to the code, but it also ensures that we're writing the right documentation in the right place. So this type of documentation will be available both for LabKey components, as I discussed, and then also here for LabKey API.
And if you wouldn't mind, just because we've got one more minute here, going a little deeper on what's included in LabKey components, kind of that upcoming V1 that you mentioned. You had the kind of bullet list in the slide, but maybe kind of the doc view or what we're trying to support.
Yeah. Sorry, I did bring this one back up because on the right side, this is our initial set, which you see here with this detail panel down through with query models. So when you might be able to understand the grid panel, the editable panel is a editable version of the detail panel, which is a row-based view look at a query information. So with edit detail panel, you can actually edit one of those in line. So if you were in Sample Manager, you would probably experience this, or Biologics, you would experience this. This is where you can go in and say, hey, I actually want to change some field on a given row. And this will present a nice little form and then allow them to edit that in line. The new thing we've added is this with query models paradigm. And so what this is kind of a component wrapper that allows you to dynamically load a set of queries that will be managed and loaded by this component. So this wrapping component loader will help manage anything about the state of the models. And what it means is that your model that you want to, or sorry, that your component that you want to wrap, it will have access to all these query configs without really having to do much in the sense of the details of loading those out and making the request to LabKey. You can just specify the interface for what you need to say, like, hey, I need this schema and this query with these filters, for instance. And your component will have that data made available via a query model. So that's something you can see as upcoming. I can go here to it real quick and yeah, it doesn't have an example yet. We're still working through some of the documentation here, but we have examples that we're going to be adding to this documentation just to make it real clear about how to leverage these tools. All right. Well, I think that's it for my time. I'm going to hand it over to Binal, and she's going to talk about bringing your data together. So let me stop my screen share real quick. There we go. Thank you.
Hello, good morning, everyone. Thank you, Nick. Welcome to the Tech Talk. In today's presentation, I will be going over how to bring your disparate data sources together in LabKey. This is a very high-level presentation, but before I begin, if you have any questions, please click on the Q&A button below and post your questions there. So I'll start with a theoretical example scenario. What you're seeing here is on the left side, let's say we have clinical study data in SQL Server, we have demographics data in Oracle, and essay data already uploaded into LabKey. I'm not going to go over how to upload and create essay designs as part of this presentation. We have amazing tutorials on labkey.org for that. So let's say we have all these data, disparate sources of data. And our goal here, which is listed on the right side, is to utilize LabKey server. So let's say we want live views of the external data from Oracle and SQL Server. We also want an ability to join demographic and clinical data so that we can create custom queries, reports, and analyze all that data. We also want to take advantage of validation and transformation that LabKey has to offer of this demographic and clinical data. And we also want to allow essay viewers limited access to, let's say, demographic data, so we can join and create customized reports and queries. So before we can do anything with these external data sources, what we need is to connect. We need LabKey to connect to these external data sources, and that is done via JDBC, defining an XML configuration file. You don't need to be an expert on JDBC here. All you need is user ID, password, and a URL to your data source. And LabKey can connect to these various external data sources, such as Postgres, Oracle, SAS, MySQL, SQL Server, and Amazon Redshift. It is important to note that these are not LabKey's underlying databases. These are what LabKey can connect to and communicate with as an external data source. Most of you probably already know that LabKey's underlying databases are Postgres and SQL Server. So throughout the presentation, I will be building upon this slide. So what you're seeing on the right side here is the LabKey server with essay data already uploaded in LabKey, as I mentioned earlier. And on the left side, we have external data sources such as clinical study in SQL Server and demographics in Oracle. And we have established a JDBC connection to these external data sources from LabKey. So that is actually not enough to do anything just yet. What we need is to define an external schema from the LabKey UI. What that is, it is a step where you allow external data sources to be viewed in LabKey and how you view it and what tables you might view it. So the schema name, for example, the first configuration. By the way, this is actually a UI in LabKey that you can fill out. So the schema name would be basically an alias name. That's the name you'll see in LabKey about your external database. And the key ones are tables. For example, you can select from the dropdown what tables you would like LabKey to see from the external database. And you can apply metadata on that. What that means is you can format how the table is seen in LabKey. For example, in this case, what you're seeing on the screen, the column name is address line 1. If you don't want to see that, you can add column title so it is shown as a street address. So it's basically a metadata to format the column headers and also the data. So coming back to our scenario slide, say we have established JDBC connection here, and we also have created external schema each for clinical study data on SQL Server and demographics data on Oracle. Now it is key, it is an important point to note that This data is actually not in LabKey. By creating these two configurations, what we have established is basically sort of a doorway or a portal to these external servers, so we can view that data in LabKey and basically leverage a lot of this stuff, a lot of the functionalities that LabKey has to offer that allows us to view and analyze live data, create visualizations, charts and graphs, for example. We can also create apps using the LabKey APIs and create custom queries and reports. So just to recap, the benefits of an external schema is that it allows you to display, analyze, and report on data stored on any database within your institution. You can also build LabKey queries and applications using the live data from the external database. And it is indeed a quicker implementation without having to copy data into LabKey. So why not implement or integrate data this way for all the cases? Why do anything else, right? So there are a couple of caveats to just having viewing the live data through external schema, and that is one of them. The major ones. One is that you cannot join data from different data sources. For example, we cannot join tables from external Oracle database to our SQL Server external live view data or any of the internal databases. And it also, there is little to no validation or application of business rules on that external data. And you cannot use built-in LabKey data structures and associated functionality, such as study data sets, assays, and list. With study data sets, you get to manage data set or study table level security, for example. So coming back to our scenario slide, we have JDBC connection, external schema setup, and we are viewing the live data, as I was mentioning earlier. We cannot combine the views or data from these two external schemas, or we cannot combine what's already in LabKey. So what is the solution here? So one of the solutions, or the solution, would be to copy that data into LabKey via ETL. ETL stands for, as most of you already know, extract, transform, and load. So our JDBC and external schema setup actually was not in vain. We can still do all these things with the setup. This setup is also very critical for our ETL. It actually takes care of, partially takes care of the extract part of the ETL. So we can ETL the data or copy the data into LabKey. So some of the ETL features are that you can run them ETL manually. What that means is that you go to the LabKey UI, to the data integration module, and you click on a button to run the ETL. Or it can be on a schedule. You can set a cron job that, that allows you to run the ETL at a particular time every day, or any calendar day, like for example, Thursday at 2 a.m., or run it every hour. You can also set the ETL to append the data, which means that you can, it just appends or adds a new row to the end of the table. You can also set it to merge. Merge is based on a primary key. If it finds a primary key, then it updates the old value with the new value. Or if it doesn't find it, then it just appends it to the end of the row. You can also truncate and re-import the data every run. You can also set the ETL to update incrementally. So these updates are based on a timestamp. So the timestamp needs to be there in the external tables, and we store the timestamp of the last ETL run in LabKey. So then the comparison happens between the two, and if the timestamp in the external table is later than the last ETL run, then it is time to update that row. You can also delete the rows in LabKey based on an audit or deleted rows table that probably exists in the external tables or external database. And these features or configurations are actually defined in an ETL configuration file, which can be a permanent part of a module, or you can just define it from a UI as well, which would be specific to a server. Another ETL feature is transform, the T part of the ETL. What that allows us to do is allows us to update data values and shape as it is being imported into LabKey. For example, you can do unit conversions. You can also filter the incoming data or change number of columns. For example, if you have columns such as study and phase, but you would like to store that separately in LabKey, so you can filter it or aggregate that data for later use. You can also transform the data based on data already in LabKey. What that means is that, let's say there is a weight data, incoming weight data from the external server. There is height data already stored in LabKey. So you can query that height table, the data that has height, or table that has height data, query that and create a new column called BMI, body mass index. Transform can be also based on aggregate data across multiple rows. For example, you can calculate cumulative blood draw data across multiple rows that's happened previously as part of the previous ETL runs. Another key feature of ETL is validation. So what validation allows us to do is to catch source data errors on import. Validation happens on a row-by-row basis for a given table. It can be applicable to data entry as well. So once you have set the validation and transformation, it is not in vain. Once you want to enter new data or edit the existing data, those rules are still applicable. The example of the validation rules that you can include, such as if there's a gender male and for the pregnant value it's true, then it should throw a validation error. Such errors can be on a single row basis, or you can throw multi-row errors. And you can also catch the errors based on previously imported data. If the new incoming data is the calculated data, for example, blood draws, is exceeding a certain criteria. So the mechanism to transform and validate the data, transforms is generally done via SQL queries. For example, you can do mapping of the columns from external tables to the LabKey tables in SQL queries, and some minor validation checks in SQL queries as well. And you can also use LabKey trigger scripts to do such transformations. And validation is most generally done with LabKey trigger scripts. So LabKey trigger scripts are not database trigger scripts. You must have heard the term trigger scripts in the context of database, but these in LabKey, in the ETL context, these are Java or JavaScript files, which is where you code your transform and validation rules. So once the data is ETL'd in LabKey, what is it that you can do? You can do a lot of fun things. One of the key ones is join data across schemas and tables. This was one of the main reasons we decided that we need to ETL or copy the data into LabKey, because we were not able to do that with just having external schema or live data. You can create lookups, you can group data and calculate aggregates, you can add calculated columns, format data, create visualizations such as charts and graphs, and you can also connect to other data visualization analytics tools, for example, Spotfire. So coming back to our scenario slide, we have JDBC connection, we have external schema setup, and you can still do all these things with the external schema. You can do a view and analyze live data and so forth. But with the data copied into LabKey, we can even now do more and leverage a lot of the functionalities that LabKey has to offer. So we can now join the data across sources. The data is already transformed and validated. You can also use the built-in LabKey data structures, such as the study data would be in the study data set tables, which allows us to manage data set level security. You can also create apps using LabKey APIs and analyze and visualize data. So one of LabKey's signature or key features, among many others, is our folder-based security model, where you can give read or write access to users or user groups in a given folder where the data resides. So let's say in our scenario, our clinical study data and demographics data was ETL'd into study and demographics folder, and assay data was imported in assay folder. Now in assay folder, we would like to create reports joining just a limited amount of demographic data. And we don't want to give full access to the demographic data to the assay users in this folder. So what we do is we create a linked schema. So linked schema, the concept of linked schema is very similar to external schema in a sense that it kind of creates a doorway from one folder to another. In external schema, we were creating, quote unquote, a doorway from LabKey to external tables. In this case, we are creating a doorway from one folder to the other folder. So to demonstrate that, here I have my assay folder where the assay data is imported, and I have study and demographics folder where we have ETL demographics data. So what I've done here is I've created a linked schema to this folder, and I'm viewing a filtered view, showing a filtered view to the users of just the US participants from this table. So to recap some of the linked schema functionalities, we can choose to expose some or all of the tables from the original schema. Linked tables and queries may be filtered so that the only subset of the rows are shown, as demonstrated in a previous slide. We can also tailor cross-folder queries and views for a specific group of users. So for example, we want to show male participants ages 16 to 25 enrolled in HIV study to gender and AIDS studies group. Another example, show all US participants enrolled in HIV study to US studies group. So we can do such thing, just so to demonstrate that. Let's say I have a folder A where I have created a linked schema to my study and demographics folder with a filtered view of US males between 16 and 25. And I've given US studies group read access to this folder A. And in folder B, I've created a linked schema from folder B to, and these folders, by the way, are assay folders. And I've created a linked schema to, again, demographics table, study and demographics folder to get a filtered view of this data, which is US participants in HIV study. And I've given age and gender studies group read access to folder B. So if this group tries to access this folder, then we'll get user does not have a permission. And if this group tries to access this folder, then we'll get this error. So what you're seeing is a demonstration of how we're tailoring cross-folder. So this is cross-folder queries and views for specific users and groups. So to recap, we first introduced the external schema, which is an extremely quick setup to view the data on external servers. It gives you live views of external data. So you don't have to copy data into LabKey, makes it for a very quick and easy implementation. And then we saw the caveats of doing that. We were not able to join that data, so we decided that we need to copy that data into LabKey through ETL process, which imports data into LabKey. It gives us an opportunity to validate and transform data as it is imported. When data is in LabKey, we can join data for reports, queries, and analyze them, create visualizations, and so forth. It is important to note that it is a snapshot of data and not a live view. But the benefits of having the data in LabKey is more than just having a live view. We can leverage a lot of the functionalities that LabKey has to offer once the data is in LabKey. And lastly, we talked about link schema. If you have security needs to restrict access, so we can give access to subsets of data from a different folder, or it also allows joining of data across folders. So this concludes my presentation. I would like to thank Marty for helping me with these slides. Josh, Molly, and Will, thank you for all the feedback. Any questions?
Okay, I'm going to help out with questions. I got a little head start while Binal is doing her presentation.
You're mute, Marty.
Sorry, I hit the two buttons too fast. So I'm going to answer some of these questions. I got a little bit of a head start looking at them while Binal was doing her presentation. Binal, let me know if I'm missing anything on any of these. So one question is, can the query data be surfaced as a data grid in LabKey? I believe this is talking about the external schema. Binal, I don't know if you want to go back to the page or the slide that had the external schema set up. And ETL is one way to do that, is by bringing that data all the way into LabKey. But you can actually view that external schema data through a data grid within LabKey. That metadata, you can actually apply metadata to it as well. You can resolve foreign key lookups between what's on the same server via this metadata. And so you could make data grids within LabKey using like an external schema and make that available for viewers to see. This next one, I'm not sure I got the best answer for, but I might have to follow up on it. Is the external schema's underlying database management system partitions functionality allowed in queries from LabKey as part of the transform step? So as Binal talked about with the transform step, it's generally done with either JavaScript trigger or a Java trigger. And it depends on what kind of functionality you're wanting to do, or you could just transform your data with a SQL query, a LabKey SQL query. You'd have to look at our LabKey SQL reference, which is all posted online in our documentation, to see what partition or what functionality exactly it is that that you would want supported as part of that transform step. If you were going to use a Java trigger, we'd have to look at our JDBC, what we're supporting with our JDBC interface right now. If that's is kind of what you're looking to do, is something along those lines.
Marty, this is Josh Eccles. I can jump in with an idea on that. I assume that part of the motivation there is to be able to use SQL syntax that is not supported by LabKey SQL, but is supported natively by the underlying database, Oracle or Postgres or what have you. And the way that a number of groups have been successful in doing that is they've created a view in the source database itself, which allows them to use whatever syntax that database supports natively, and then pull from that view as if it were a table as the source of the ETL. So that's a way to let you do things that aren't supported directly in LabKey SQL without having to do kind of the code-based transformations, like you mentioned for Java or JavaScript manipulation.
Josh. All right, so another question. So create a destination schema first, and then the link schema, and then the ETL. So it's really kind of the order was to, it's an external schema, and that connects to the external database. And really, so that's part of our community edition. You could go in right now and create external schemas to external databases. Might be a good way to start looking, just to look at your data within LabKey. And then if you want to bring that data into LabKey, then you do the ETLing, and that would actually use that external schema to bring that data into LabKey. And then if you want to do, as Binal was talking about, basically link data across folders, where you're kind of providing a window into a subset of data that's controlled by the folder boundaries or the folder permissions, then you would do the link schema. So link schema is kind of a separate thing. It's not really part of the ETL process. It's just a way to connect across folders and across those permission boundaries to allow a limited access across there. Let's see, do you folks use the method to pull information from REDCap, for example? We do have REDCap integration. That is, I would have to follow up with you on that one, or we'll have somebody follow up with you on that one. I'm not as in tune with REDCap. That might be a JDBC integration, but I would have to look that up to be, but I can follow up with you on that one. But there's a lot of documentation on our REDCap integration, so I recommend anybody just Google LabKey REDCap, and you'll get lots of documentation on it, which is pretty much the best way to find any of our documentation. Just go to Google and type in LabKey and whatever it is you're looking for.
I can comment a little bit more on that, Marty, as well. The REDCap module that we have that you mentioned doesn't go directly against the underlying database. It goes to REDCap's APIs and extracts data that way. And so that's often, a good question on any given system that you're looking to pull data from is what entry points does it offer? Does it have an API that might be a more robust way to do that, or is kind of the little bit more of the backdoor opening a connection directly to its underlying database? Is that the best way to go? But for REDCap, the module goes against the I think it's an HTTP-based API instead of the direct JDBC connection.
Okay. Let's see. Is there a way to see query dependencies in the server? If so, does it include external and linked schemas? So we've just added this. I think Adam talked about this recently. The ability to see dependencies in the server on your queries in your schema browser. And I believe that would include external and linked schemas. I would have to verify that, but that capability in general is there, and the way I understand it, it will include these, or it does include the external and linked schemas. Does LabKey support transforms into FHIR? So I'm not as familiar with FHIR. You can really do transforms into whatever you want with your data. We don't have like a built-in standard for, it looks like fast healthcare interoperability resources. So we're not, and I guess it's part of HL7. We don't have anything that I'm aware of that would make that happen automatically, but you can do basically whatever you want in transforms. You can write your own transform scripts or trigger scripts that will do these transforms. I don't have a great depth of knowledge into the FHIR, but it's really just the trigger script process is wide open to do whatever kind of programming you want into whatever format you want or whatever transformations you want. Okay, so I think our time slot is up. I will pass this off to Stuart and Isa. They're our hosting masters. They're going to be talking about best practices and benefits of LabKey hosting. Anything I didn't get to or I didn't answer well enough, we'll get back to these questions, and yeah, feel free to follow up if you didn't get the answer that you wanted also. Okay, thanks everybody.
Sweet, so I guess we're up. Thank you for that introduction, Marty. Give us just a second to get it shared.
1 second here. All right, so hopefully you can see my screen here. Great. All right, thank you, Binal, and all the other presenters today. Hopefully everyone's been enjoying the great content of the 2020 LabKey User Conference. My name is Stuart MacDonald, and it is my pleasure to share with you some best practices today about hosting LabKey. My colleague Isa Farnik and I are here to share some great things about that. So let's get started. So during our session today, we'll have a brief overview of what is cloud hosting and how that relates to our LabKey hosting offering. We'll cover our take on best practices for running LabKey in the cloud and finish off with a brief overview of our cloud service offerings. So what is cloud hosting? Well, cloud hosting is this generally means that you're running virtualized servers and virtualized networking services in someone else's data center. So this is something typically referred to as blank as a service. Some important attributes of cloud hosting are that your system is isolated. So your network and your computing resources are isolated from other organizations, even though you might share the underlying hardware that runs those resources. Cloud hosting has your data. You manage your data, but it's just as I was saying previously, it's on someone else's physical computer. One important attribute of cloud hosting is it's a pay-as-you-go model versus the traditional model of hosting something yourself in your own data center, where you have to kind of, before you're able to do that, you have to specify and figure out what you think you're going to need from a computing and network resources standpoint, go out and purchase that, and then deploy it, and then hopefully you guessed right. With cloud, you don't have that challenge. You can deploy your application into the cloud, and you can either scale up or scale down that infrastructure based on your needs. And you only pay for what you use rather than what you think you might use. Another important attribute of cloud hosting is that there's generally a programmatic interface, an API, that allows you to change or modify that infrastructure programmatically. So I recognize that our attendees today are probably not all IT experts and probably don't know about all the other aspects of different types of cloud services that are out there and different flavors of cloud hosting. So I'm going to hit briefly on a couple of those types. We'll talk about software as a service, infrastructure as a service, and platform as a service. So what's software as a service? Well, this is generally a subscription service where you pay a monthly fee to access the application. Some examples are Zoom, which is like we're using today, WebEx, Dropbox, and even Facebook. Some important attributes of software as a service are, it's generally multi-tenant. There's generally a single instance of an application, but there are multiple customers that use that. Often, software as a service generally has low administration overhead and a minimal set of customizations. To begin using that software as a service, you frequently just deploy or add users to that application, and then you configure the features and options that are available in the service. I often use analogies to help people understand these things. I kind of like them in the sense because it helps me understand things too. So we'll use a theme today about dwellings. And software as a service, you can think of it as a kind of like a weird apartment building where every unit is the same and they all have the same floor plan. It's very, very cookie cutter. So what is infrastructure as a service? Well, this too is typically server and network infrastructure services running in someone else's data center. Some examples of this are Amazon Web Services, Microsoft Azure, and Google Cloud. These services are very much a do-it-yourself type of system. So in keeping with the theme of dwellings and analogies that I talked about previously, this one's a little bit different, and that you can think of this infrastructure as a service as more like, instead of a dwelling, you go to the big home improvement store and you have a wide array of vast things you can choose from. You have lots of tools and supplies and other things for your home, but you can't really buy a home there, or you can't really buy a dwelling or anything like that. It's kind of really, you know, at the home improvement center, it's really up to you to take those supplies and turn it into something useful. That's essentially what infrastructure as a service is. Some key attributes of infrastructure service: it's very has a high level of customization. You have a wide selection of various services and resources that you can use. But that also means you also have a high level of administration overhead or skills required in order to use those resources and turn them into something useful. Our last as a service type that you might hear about is something called platform as a service. In general, platform as a service is you don't really hear much of this marketed too much, other than it's really marketed towards developers. Essentially, platform as a service are services that developers use to deploy and run their applications. It allows them to spend less time and energy on managing the underlying compute and network infrastructure, and allows them to focus more time on running the application. So in keeping with our theme of dwelling, you can kind of think of platform as a service as like a tiny house. You have kind of all the core services there, but you have kind of very limited aspects of what you can do with those. Some key attributes of platform as a service are there's a moderate level of customization. Frequently you have just a few things that you can tweak. And then it also requires a moderate level of administration. You've got to manage some aspects of the deployment. So what is LabKey cloud hosting? Well, it's a combination of infrastructure as a service and software as a service. It's a fully managed service that manages the aspects of running LabKey and combines that with the power of LabKey software and running it in the cloud. So in keeping with our dwelling theme as an analogy, as I've been talking about, you can think of LabKey cloud hosting as something like a super fancy condo where you have your own entrance, a bellhop, and a concierge. It's single tenant, so all your services are isolated for you and your organization's use only. It offers a moderate level of customization. You have full administration access to the LabKey application, but without the headaches of keeping that system up to date and tuned. It offers low overhead, We take on the challenging aspects of keeping the system up to date, and that ultimately lowers your costs in both area of time and effort. So my colleague, Isa, is now going to talk about some of the 3 key approaches that we use in developing and deploying the LabKey Cloud.
Hey there. So as Stuart mentioned, there's 3 key approaches that we use when developing the LabKey Cloud. They consist of design, automation, and defense. So we'll be going through these and talk about them. So first up, design. We start with a tiered application design that separates out the web application layer from the database layer. We use network segmentation to isolate client LabKey applications from each other. Next, we use network access control lists, or NACLs, and firewalls to limit the network traffic to only that which is used by the LabKey applications. And of course, we've implemented encryption everywhere. So at the OS level, at the database level, the file system level, and the transport layer. So some examples of what that means, because it's a little bit of a word salad, is so file system backups, for example, are stored in an encrypted fashion, or database snapshots are also encrypted while they're stored. And of course, we have HTTPS, so traffic as it enters and leaves the application, and the virtualized network that we mentioned earlier is encrypted. So automation. Automation is a big part of LabKey cloud hosting. So to implement a lot of the features and functionality that we're going to be talking about, we have employed automation. It's achieved through automation. So it could really be its own presentation. So I'll try to keep it semi-brief, but I'm going to go into a little bit more depth before we get to defense. So thank you. So as we built the LabKey cloud hosting platform, it became clear to us that while it is possible to build and deploy a cloud environment manually, it becomes increasingly burdensome to maintain that environment over time. So this graph is trying to demonstrate that while the initial effort is high to automate the deployment of the environment, the risk and cost of maintaining the environment thereafter actually decreases over time compared to a manual deployment that requires continual updates. So if you contrast an automated deployment with a manual deployment, have a lower initial cost of effort, but the maintenance of the environment increases over time. So the risks, you can actually categorize the maintenance of a manually deployed environment increasing as higher risk of configuration drift, and also higher security risks as you are having to manually apply security updates. We can do the next slide. So why automate? It's probably obvious for lots of reasons. My favorite one is you get your infrastructure as code. So in my mind, this is the #1 reason to automate pretty much anything. You already know what good code management looks like, and you know now you can do that with your infrastructure. So it allows you to make changes and plan changes, test changes, review changes, all the good stuff that you do with your regular code bases now applies to your infrastructure. And I feel I should tell you all that you narrowly avoided me using some truly garish word art just because I couldn't figure out how to get it into Google Slides, but just be thankful that all you had to deal with was the little reflection there. Can we get the next slide? So we use a number of tools to automate LabKey deployment and LabKey cloud hosting. For provisioning, there's Terraform and Packer. For configuration, there's Chef. For auditing, there's Inspect, AWS Inspector, and Wuzza. And then for monitoring, there's Splunk, Wuzza, CloudWatch, and OpsGenie. So I think we have a couple more than that, but these are like the core tools. So we've had a lot of success with something called the blue-green deployment model. So this is where you have your first copy of the infrastructure, your blue copy. And then when you want to upgrade that infrastructure, you stand up a second copy, your green copy. And once everything's all set up and put together, then you can transfer traffic from the old blue copy to the new green copy. And this has a couple of advantages. First, and almost foremost, it allows you to do fallback. So if for whatever reason, your new instance of the application and infrastructure isn't working or isn't set up correctly, you still have the old one available to you to revert back to. So it also causes less service disruption because the only service disruption you actually have is when you're transitioning traffic from like the old instance to the new instance, rather than having to turn everything off, stand up a new copy, and then route traffic to that copy. So, and another, I've already talked about it a little bit, but another advantage of having a blue-green deployment model is no more in-place patches. So you're not going in and taking some ancient like virtual machine, for example, and applying a bunch of patches, installing OS updates. Instead, you're standing up a new copy of this virtual machine and applying all your changes to that. So it keeps you from falling into that rut of having a really old copy of everything and having to manually update it. Can we get the next slide, please? So the next approach that I'm going to talk about is defense. It's easily our most important approach. As mentioned earlier, we considered security as a part of the design. We use firewalls and network access control lists to restrict network traffic to only what the application uses. In addition, we also have implemented a web application firewall. So this allows us to block known bad actors or IP addresses, or categorize network traffic that might be intrusive or unwanted, and deny that at the application layer, which is nice. So in our compliant cloud offering, we implemented even more defense type strategies. So that list includes intrusion detection, prevention, log monitoring, and vulnerability scans. We'll talk a little bit about that later. So just some high level best practice takeaways that we've come across. So the first item on the list here, plan for change. A rigid design does not take into account future changes that can make future work more difficult. So a simple example is with those network access control lists. On a lot of cloud platforms, including AWS, the one that we use, the number of rules in that list is fixed. So what we've done is actually leave gaps in the rule numbers, so that allows us to come in later and add rules that we might have had to change. If we had just crammed that list full of rules to begin with, we wouldn't have anywhere to go to make those changes. So definitely consider using a cloud provider. Cloud providers give you access to more tools than you would likely have on premise. And in addition, they have a shared responsibility model. So that allows you to shed some of the compliance obligations and the maintenance obligations that normally you would have to deal with yourself if you were on premise or if you were using your own organization's IT infrastructure. So definitely prioritize security and defense. If you don't make it a priority, I can guarantee that somebody else will, and you don't want to be caught flat-footed and scrambling. So as I already shared, investing in automation has significant rewards. Hopefully that's obvious through this presentation, all to enforce, audit, and validate design decisions. And of course, use encryption anywhere. So a last couple ones, deploying manually with no automation is definitely a recipe for failure. Have some automation. And then lastly, compliance is more than just implementing security infrastructure design. This happens a lot. You hear people who want to be compliant, but don't plan and don't do all of the extra steps apart from just managing infrastructure to get to compliance. So there's a substantial amount of work and effort involved in implementing the supporting policies, procedures, and documentations that are required to meet compliance obligations. So plan for that. So I'm going to hand this back to Stuart now. He's going to talk a little bit about our service offerings.
Yeah, so as we start to wrap up, let's briefly talk about our LabKey service offerings. We offer 3 tiers of cloud hosting: starter, compliant, and starter, professional, and compliant. Our starter tier is typically for smaller labs and organizations that are just starting to use LabKey. It has a moderate level of performance and a single instance of LabKey. It's fully managed, and you gain all the benefits that we've been talking about in our best practices. It's secure by design, and we take on the responsibility of updating the operating system and all the other dependencies that are needed to run the LabKey application. And of course, we manage the software updates associated with LabKey as well. Our professional tier is our most popular. It offers 2 instances of LabKey, a staging and a production instance. The staging instance allows you to test new versions of LabKey or other changes that you might need to make in a test environment so that you can test them before promoting them into your production environment. The professional tier offers improved system performance and storage over the starter tier. And of course, you get all of the benefits that we talked about in the starter. And we also extend the backup retention history. Our compliance tier is for those organizations that have compliance obligations. In addition to added storage and backup for those that are needed for those types of compliance operations, we beef up the system performance over the other tiers and add additional storage, as well as the security and services and protections that we talked about. And those include additional things such as intrusion detection and prevention, log monitoring, vulnerability scans, and the security ceremonies and things that need to be done associated with that. You heard perhaps earlier today, Adam talk about the FDA MyStudies. That application runs in our compliance tier. So why choose us? Well, we recognize that installing, running, and keeping LabKey up to date is challenging. Our services combine the skill and knowledge of running applications in the cloud, along with the expertise and best practices of running LabKey. You gain the benefit of all the best practices we talked about today, and we offer a fully managed service. So it takes the pain and suffering out of running LabKey and takes that burden off of you and your organization, and allows us to take that burden on and help you achieve your goals. So this allows you to focus on changing the world, and we'll handle the hosting. All right, so we can take your questions.
We've already got some in the chat. So I'm seeing one. Do you automate blue-green deployments? Do you also do blue-green deployments just for whole server upgrades? Or do you also do it for module deployments and modify database schemas? So
you want to do this or shall I?
I can do it. So for LabKey cloud hosting, we generally do full blue-green deployments for LabKey version upgrades, or if we need to make like deep changes to the infrastructure for a given customer, then we'll deploy a brand new environment with that customer's data applied to it. So generally speaking, we wouldn't do a blue-green deployment just to update a module, but we'd do a blue-green deployment if we were upgrading the version of LabKey. So we've got another question here. Let's see. Is LabKey investigating container platforms, things like Helm charts and Doe deployments? We'd love to. There's an internal initiative to get our hosting infrastructure into a more containerized environment, but at the moment, it's more old school with virtual machines that we manage through configuration management and that kind of a thing. So in the future, I'd like to. I cannot make any promises that user conference, but we'd love to offer that publicly.
All right, I see another question. Is multi-region deployment of LabKey possible? That's not part of our standard offering in the sense of being, generally we serve our LabKey cloud hosting in a single region, but that doesn't mean that it's not possible. We can certainly work with you if that's what your level of interest is. But we can certainly do that. We operate today in multiple regions. Our services are spread out through a few of the Amazon regions today.
So should I answer this next one?
Well, let me read it for you then. This one's yours, definitely. Do you guys have a containerized or Vagrant or Packer GitHub repos for developer environments?
Not yet, but a lot of we're a very developer-oriented company. So like if you refer back to Susan's presentation earlier, there's a lot of tooling for done through Gradle and like our new reliance on Artifactory for pre-compiled binaries of stuff that are geared towards making development a bit easier. At the moment, we do not have like a containerized development environment or an official Vagrant or Packer manifest or Vagrant file that we offer. But that isn't to say that we don't care about those things. Developer ease is very important as a company. So
I would add that we do have some examples of a container in our LabKey samples repo that we have. We update that periodically. So if you need a container for an example for a developer type of deployment, there is one that you can take a look at there. Okay, next question. So I think be joint one for you and I. Is it possible to add an additional environment or two within a cloud deployment? For example, suppose a group was using Cloud Professional but wanted a QA environment in addition to the product or production and staging environments that come with the professional package. Could this be set up? So the answer to that is yes. We have these general tiers that we offer services for, but that is a baseline for you to be able to offer services for. So we do have custom use cases, and we've done those in the past. So for example, if you wanted another environment, that's certainly possible. And rather easy for us, we would just add one more deployment to our model and use the automation to do that. Isa, you got anything to add to that?
No, that about sums it up.
All right, I think that's the last of our questions, unless we have any more. We're right about at our time. So a few reminders as we end the conference. Please register for user testing using the link in your conference emails. It's your input that we use, and it's very valuable to us to help continue to develop solutions that can make the most impact for life sciences organizations. So please take advantage of that. We really value your input on how the application is used. Session recordings will be available soon. Please keep an eye on your email for those, as well as feel free to share those with your colleagues. Should you have any questions about any of the sessions presented during the conference, please feel free to email us at communications@labkey.com. And with that, our first virtual LabKey user conference comes to a close. Thank you to all of our presenters, especially our partners, and of course the LabKey team for making this a great virtual LabKey user conference. Hopefully next year we will be able to do this in person again. So please keep an eye on your email as we plan to continue hosting more informative webinars as we've done throughout this year. And we hope to see you at one of those events soon. Thank you again.